So cycle expand, simplify, and factorize fractions. Okay. So in this, when your powers are, when the algebraic powers could be the base or the powers later on. Okay. When the algebra is the power, they are what we call exponents, and they are heavily linked to logarithms as a subsequent chapter later on, actually. So just think of them as new grammatical rules for algebra will do in general. Okay. Okay. So if you look at this set of rules that I have on the left side, right? So I'm sure you remember them. So what's the first rule leading you to?
AM plus n.
Yeah, okay. So whatever exists for multiplication will exist for division. Then this will be a to the power of m minus n. Okay.
Yeah.
The third one?
AM times n.
Okay, good. So never mix up the first one and the third one, okay? So the third one, how is it simplified, right? It's actually like a to the power of m times a to the power of m times a to the power of m n times, okay?
Okay.
Hence it leads to this guy actually, all right? Okay, and then a to the power of negative m?
It's 1 over am.
Yeah, okay, so when you have negative powers, always turn it's like a fraction, okay? So whenever I see a negative powers, right, actually I try to do this right away.
Yeah.
I want to do with positive powers only. I don't want to do with negative powers, right? And a to the power of half?
Square root a.
Yep. And a to the power of 1 over m?
M square root a, like the m power thing.
So square root actually means power 2 here. So there's always invincible 2 here all along, okay? But we don't really write it usually. So this is like this, okay? So it's called.
What is the thing actually called?
Sorry?
What's this thing actually called, like the small number?
So it's the m root of a.
The m root of a. Okay.
Okay. So when it's power 2, it's called square root of a. When it's 3, it's called cube root of a. Okay. So when let's say it's 5, it will be called fifth root of a, and so on and so forth.
Okay.
Okay. Okay. And if you have the combination of the previous two laws.
Sorry. So then 1 over a 1 over square root a.
Okay, it's not square root, right? Because it's m here, right?
So 1 over m root a.
Yes, that's right. Okay. Like this. Okay, Ken?
Yeah.
Okay. And the next one is my favorite rule, where you have power 0, it just equals to 1 right away.
Yeah.
Okay, so whenever I see this or this, I will simplify them right away, rewrite them into the form. Okay.
Okay.
Okay, so all this, right, has been a common base of A, and the rules about pertaining to the powers. So now the next two rules are when you have the similar powers but different base. So we can think of them the same way. So this will become like this right now. Okay.
Yeah.
So these are the rules of indices that are not inside the formula sheet at all. You need to be versatile with them, learn them like a new language for your E-math papers, especially for the paper 1. Okay.
Okay.
Okay, so I don't think you have any issues with this in general, right?
No, not really.
So we'll go through a few quick questions on this, and then we can move on to indices. We may take less than 2 hours since I reckon the second person is not joining today.
Okay.
Okay. Okay. So let's say now here all these questions are pertaining to numbers only. So how will you do 1A in general without use of calculators?
Okay, which one is 1A?
Oh yeah, this one. Oh, sorry.
Yeah, I tried to print the work, but I don't know why my printer didn't want to let me print it.
Really?
Yeah.
Yeah.
Because I don't know, sometimes with Word, my printer doesn't let me print, but usually with Google Docs and PDF, it is no problem.
So did you try to print off your phone or your computer?
My computer.
Which printer are you using?
Epson, that's the brand, but I don't know what the model like exactly is.
If you try to print it off your phone, does it work?
It's a USB, so I can't even print it off my phone.
Oh, okay.
Yeah.
Then maybe that explains why.
Oh.
Okay. like the printer is too old and the Word version is relatively new and the thing doesn't sync up in that sense. Whereas
Yeah.
it's more like the versions workable for are backdated all along.
Yeah.
Okay. Okay, that one is okay. Let's get 1A first. How will you solve questions like 1A in Indonesia?
1 over 0.25.
Okay. So which is equals to
Oh wait, 1 over 4.
0.25 is 1 over 4, right? So
Oh,
this
so it's 1 over 1 over 4.
okay. Get it? So you're supposed to evaluate like this in the EMAth papers. All right.
Oh, okay.
Okay. So part B is obviously just equals to 1. This is power 0.
Yeah.
Okay. What about part D? How will you do questions like this?
So half to the negative 2 power. That just becomes 2 to the power of 2, right?
2 to the power of negative 2, right? Okay. So there's a negative power, right?
Yeah, so what is it? Yeah, because since it's a negative power, you would flip it, right?
So it
So it
becomes
becomes 2.
over 2 to the power of 2 first. Get it?
Wait, but isn't it 1 over 2?
Yeah, yeah. 1 over 2? Why 1 over 2 though?
Wait, which question are we looking at?
Part D, part D.
Oh, I was looking at C, sorry.
Oh, okay, okay.
Uh,
We can look at C also.
yeah,
Okay. So C, how will you do it? So it's
yeah, so it becomes 2 to the power of
1
2. Yeah,
times
times 1.
and divided by
Uh, yeah, just divided by 9 over 16.
okay. So this will give you 4 divided by 9 over 16, which is equal to 4 times 16 over 9. And then you can just simplify from there. Then, okay.
Yeah.
Get it? Okay.
Yes.
Okay. So that's for this one. Okay. Part E, how will you do this?
Um, when there's a fraction in the power, what do you?
No, but the key point here is they all have the same base, right?
Yeah, so you
So we can
can.
actually simplify the powers right now, right? So this okay, 3.5 is 7 over 2. So this is times 9 to the power of
Oh, because you can just add and subtract the powers if you want.
that's right. Okay. 17 over 4. Okay. So this will just be 9 to the power of 7 over 2. This is divided, sorry. So this 7 over 2 plus 7 over 4 minus 17 over 4, isn't it? Get it?
Yeah.
Then you can simplify this accordingly. Okay.
Yeah.
So in the EMAth papers, we expect students to simplify all this accordingly, right?
Okay.
Okay, so we will try one more, part F.
Powers. So you do 7 times 3 to the power of 7, which is just 21 to the power of 7.
Okay, which one? Which part are you looking at?
Oh, the 7 times, because it's 7 to the power of 7 and then 3 to the power of 7, right?
Okay,
So you can make it as 21 to the power of 7.
good. So this will be 5 cubed, 21 to the power of 7 over, and then
Then 25, you know, it's 5 to the power of 2.
good.
And then 21 to the power of 7. So then you just cancel the top 5 cube and 5 to the second is just 5, and then 21 cancel.
Okay.
Yeah.
Though I agree with your answer here, right? But my personal opinion is you should not group numbers together. You should instead try to break numbers down. Okay.
Oh, so like the 21, you would break it up into 7 times 2.
Yeah. Okay. So you should always try to break numbers down into their primes, which is actually an element in surds, right?
Yeah.
So you try not to group numbers together, then turn them bigger. The bigger the number, the harder it is to process it eventually, right? So you should actually try to break numbers down into their primes. Okay.
Okay.
Okay. So this is pertaining to EMAth. So this is usually part of paper 1, simpler questions. Okay. So we'll try out others. Okay. Alvin, can you see this?
Yeah. So I'm just looking for my calculator because I don't know where it disappeared. Oh, literally directly in front of me. That's right.
Alright.
So A, right?
Do every alternate question will do. So A, C.
Okay.
Right.
So x squared divided by x to the fourth, which is x to the negative second power.
Okay.
Then times x to the third is just x to the first.
Okay.
Yeah.
Okay, then the third one.
And then x to the seventh. So then it would just be x to the 10th and then y times y.
So it's like this, huh? All right.
Oh, do you have to show it in two separate steps, or can we do it in one step?
You can do it in one step actually, but I just prefer you to go through it and do this and that's all. Okay.
Yeah.
Okay. Part E.
81. So 8 times half is just 4. So 81 a to the power 4.
No, the power half applies to the 81 also, right? Not just.
Oh yeah.
So it's actually 81 half A8 half. Okay. All the elements within the bracket will receive the power half. Then same goes for the subsequent bit. So it's 27 negative 1/3. A6 negative 1/3. Okay.
Yeah. So then it would just become 81. Oh, for 81 to the power of half, are we allowed to use calculator?
No, you don't really have to. Remember, power half is just equals to square root, right?
Oh, square root, yeah. So then so square root 81 is just 9.
Good.
Then 8 to the power of 8 times half is just 8 to the power of 4.
Good.
Then 27, it's cube, it's 1 over cube root of 27.
Is equals to?
Cube root of 27 is 3, I think.
So, yep.
Yeah. And then 1 over 6 to the, 1 over 8 to the power of 2.
So a to the power of negative 2.
Oh yeah, that's what I was going to say, 1 over 8 to the power of 2.
Okay, so
wait, it doesn't make sense to put it over a fraction though.
Sorry?
It doesn't, I was going to say 1 over 8 to the power of 2, but it doesn't make sense to make it a fraction.
So it doesn't really matter in this case, so I'll explain why. So if what we have now, right, we can combine everything together, you will thus get 3a squared, right?
Yeah.
Okay, so if we have proceed with what you have mentioned, right, so this will become 9a4, 1 over 3, 1 over a squared, right?
Yeah.
So eventually you will still see this as 3 and a4 over a squared, and this will give you 3a squared net still.
Yeah.
Okay, can?
Yeah.
So you need to get comfortable dealing with all these questions also, all right? Can?
Yeah.
Okay, so I don't think you have much issues with this. Okay, let's move on to question number 3.
X plus 2x minus 1.
Okay, so the second person just joined. So just be patient with me for a while. Okay,
yeah, sure.
I haven't met her before actually.
Okay.
Hi, good morning, Natalie. Are you there? Natalie? Natalie, can you hear me? I can't hear you if you are speaking. Natalie?
Can you hear me?
Yeah. Look, okay. Can you see this and hear us?
Yeah.
Okay, so I just want to run through with you what we went through in the last 20 minutes. So we are doing lots of indices for the first hour and certs in the second hour. So are you okay with them in general or at quite a loss with them?
I think I'm okay with that.
Okay, so lots of indices, I just want to run through with you on the basics first. all these things on the left side, on the left column, have you seen them before already?
Yeah.
So you're all okay with them?
Yeah.
Okay, so what you missed just now was just like lots of indices, numbers-based questions for the first 10 minutes or so, all this stuff in general, okay with them? Or
Okay.
then any particular thing that you're not okay with?
I think the only part is the search, like some mistakes, kind of
Oh,
mistake.
so search also, so some department. Okay. So maybe this session today may be less than 2 hours in general. So I just want to see how it goes. So because if you are comfortable with search, we can move a bit faster actually. Okay. So Pavan, you can try number 3 first. How will you do this kind of question?
First, you can multiply the first two,
Say that again.
but you can't add the first two, right?
So what do you have to do then?
Because that's, then just make 4 to 2 squared, and then it becomes 2x minus 1 times 6x minus 2 divided by 32 can also be to the power of 2.
Later is 2 to the power of 5, okay?
Yeah. And then 2x plus 1. So then it just becomes 7x minus 3 divided by 10x plus 5.
Okay, like this.
Then it just then 2 minus 3x plus 2.
Minus 8 actually.
Oh, because it's divide.
Okay, can understand? So
Yeah.
So for both of you, for questions like this, right, where you have different base lurking in the question, right, in this case 2, 4, and 32, you must look at what the question is seeking right away. So clearly in this case, the question is seeking for base 2, right? And you must recognize that 2, 4, and 32 can all be converted to the base 2. And that's where you should move in that direction then, okay? So turn them all into base 2, then use lots of indices to simplify them all together, all right? So that's how question 3 is done. Okay, Natalie, why don't you just try number 4 then? Are you feeling okay already? Like you woke up late and everything, is it?
Huh?
Are you feeling okay now or just woke up late?
Yeah.
Is it? So is it okay? Try number 4.
Yeah.
So how will you do number 4 in this case?
You make the 4 become 2 to the power of 2x.
Okay, good. Okay, and then?
And then you bring the 2 over, wait. You bring the 2 over there and then the 3 over there. Wait, no, cannot.
Yeah, that's correct actually, but I just need to improve your presentation. So what do you mean by bring over there and bring over where? Is it left side or right side?
You bring the 2 to the power of 2x to the other side, to the left
So
side.
you want the 2 to the left and shift all the 3 to the right, essentially. Okay, so you will have 2 to the power of x minus 2 divided by 2 to the power of 2x, which is equal to 3 to the power of 2x minus 1 over 3 to the power of x plus 1. Okay?
Okay.
And simplifying this, what will you get on both sides now?
You will get 2 to the power of x minus 2
minus
minus 2x, and then
so
3 to the power of 2x minus 1 minus x plus 1.
It's minus x minus 1. So it should be like this, minus x plus 1. Okay?
Oh.
So this is one of the most common mistakes. So feel free to write brackets first. Sometimes the teachers will actually skip this step and then write the answer right away. But for you guys, if you need to write more steps at this year, okay? So this will become 2 to the power of x minus 2 minus 2x actually, okay? So we will then get 2 to the power of minus x minus 2. This is equal to 3 to the power of x minus 2, okay? Okay, so you must recognize that now the question is asking for 6 to the power of x, right? And where is that going to come from? You will know that 6 is 2 times 3. So you must find a way to combine the 2 and the 3 together at one point in time, okay? So there is no standard way to write all this. Okay. In fact, Natalie's way of shifting all the 2s to one side, shifting all the 3 to the other side, is really her own way already. Some people can shift it the other way around, and it's really your own preference. There is no standard or perfect solution in questions like this. Okay. So how do we actually break this up from here, right? It's like this. 2 to the power of minus x times 2 to the power of minus 2 on the left. On the right is 3 to the power of x, 3 to the power of minus 2. That means you are reversing the laws of indices. From one base, you break it up into 2 bases. Okay. Basically, the base with the algebra and the base with the numbers as the powers. Okay. So how do we simplify from here further? Okay, 2 to the power of minus 2 is actually 1/4. This guy is just 1 over 2 to the power of x. Okay, this is 3 to the power of x. This is 1 over 9. Okay, then to create the final situation that we need, right, is to shift all the numbers based stuff to one side, shift all the algebraic base, shift all the algebraic power elements to the other side. What do I mean by this, right? Shift this guy to the left and shift this guy to the right now. So you will then get 9 over 4 is equal to 3 to the power of x, 2 to the power of x, which is equal to 6 to the power of x then. And that's the answer. Okay, so the movement here is not unique to everybody. If you give it to 5 different teachers, right, they may have different ways of solving this, but you must be confident in manipulating the algebra, especially for the negative powers. Okay, so for this one, the key step is actually here and here. Okay. So please make sure that we are all okay on this. Before this is actually considered one of the harder ones for indices in E-Math. There are no longer such questions in A-Math already. They are all brought under certs in general. Okay. So Natalie and Pavan, okay with this?
Yes.
Natalie. So just to check, Natalie, you are in Sec 3, right?
Yes.
Okay. Okay, so we will try the last 2 questions for this together also. So Pavan, you will try 5A.
Okay. So 3x equals. So then the 25x plus 1, you just change it to 5 to the power of 2x plus 1.
Okay, would it be 5 to the power of 2x plus 1 or 5 to the power of 2x plus 2 actually?
Oh, yeah, I meant like 5 to the power of 2 and then bracket and then like x plus 1 outside.
So it's 3, 5 square, x
Yeah.
plus 1. Okay, so this will give you 5, 3, 5 to the power of 2x plus 2. Okay, can?
Yeah.
Okay, and then same technique as number 4. We'll break.
5 to the power of 2x plus 2. Wait, do you, can we not take put the 2 in the thing, in the brackets?
What do you mean?
Because like don't make it 5 squared. Don't make it 5 2x plus 2.
Okay,
because
then we
no,
will,
because then you can do. Can't you just say 5x plus 1, and then bracket the whole thing square, and then 5x plus 1 is 5x times 5.
okay, same thing here, right? We can actually break this up, right? Using the same technique that we did here, actually.
Oh, okay.
So this is just 3, 5 to the power of 2x times 5 squared.
Yeah.
Okay, and then 5 squared is just 25. 25 times 3 is 75 right away. Okay.
Yeah.
So 5 to the power of 2x, if you find it hard to put it in element, right? So 5 to the power of x square now. Okay.
Yeah.
So this is 5q squared. Okay. Get it?
Yeah.
So at actually in all cases like this, I encourage you all to write brackets thoroughly. Okay. So even for this, I don't want to have any like ambiguity between this kind versus this kind versus this kind. Okay, so it's always good to write brackets like this all along to remove all ambiguity. Okay, just in case due to bad handwriting or whatsoever. Okay. Okay, Natalie, you can try 5B.
For 15, change it to 3 to the power of
Okay, so just ask ourselves, 15 is what times what again? What are the factors of 15?
5 and 3.
And 5 and 3 are the root numbers already. Okay, so we will just express 15 as 3 times 5 right away actually. Okay, so this will be 3 5 to the power of minus x. Okay, so in general I don't write cross as my multiplication in senior math anymore. I'll just write dots all the time, most of the time. Okay, so then what do you do from here?
To multiply in the negative x, so it becomes 3 to the power of negative x times 5 to the power of negative x.
Good. And then
it will become like what we did in question 4, 1 over 3 to the power of x times 1 over 5 to the power of x.
Okay, can. So this is the answer. So same thing, this particular step here, if you choose not to write it, it's not a paramount. Okay, you can choose to ignore this particular step here. So from here, right, from here, we can straight away see it has 3x to the power minus 1, 5x to the power minus 1, if you wish to. Then this is just like p to the power minus 1, which is 1 over p right away, and 1 over q. Okay, so you will find your own way and own preference of presenting stuff like this eventually. Okay, some students want to see the exact 3 to the power of x appear first. Some of us can skip steps, of course. Okay, but like I said, at Sec 3 level, try not to skip too much steps first and learn to write more brackets in all your workings for the time being. Okay. So for number 6, it's the same gameplay. So I'll do number 6 then. So number 6, if you look at this kind of thing, right, don't get stumped by the complicated expression first. Look at it systematically. So you will see that in all cases, they are all base 8, 4, and 2, right? Which means that they are all hyperlinked by the base number of 2. Usually these kind of things you must think in terms of prime numbers. So 2, 3, 5, and 7 are the special numbers that you should pay a bit more attention to at this stage. So the first step must be to dump all of them down to the power 2 right away. And from then on, the simplification becomes clear. So 8 is 2 to the power of 3. 4 is 2 to the power of 2, then 2x. Then this will become 2 to the power of x minus 3, 2 to the power of 3, x plus 2. Okay? So here I'm already writing a bit more steps that I used to usually already. So from here, this will become 2 to the power of 3, 2 to the power of 4x over 2 to the power of x minus 3, 2 to the power of 3x plus 6. Okay? So the most common mistake here is the plus 6 becomes a plus 5 instead. It's not. So be careful of the loss of indices. And I should write a bracket here, in fact. Okay? Any questions on this so far? No, I move on. Then from here, the simplification process is obvious. So this becomes 2 to the power of 3 plus 4x minus x minus 3 minus 3x plus 6. Okay? And then you just simplify the answer and then you will get it. So I'm just writing everything in one single step. Most people tend to simplify the numerator and simplify the denominator first, of course. Okay? So this will be the second most common mistake. Remember, put the brackets around this. Okay? Otherwise, you will have careless mistake. So this becomes like the simplification of the powers now, right? Becomes like your classic Sec 2 work already. So this is just 3 plus 3, 6 minus 0, 0. Then 4x minus x, 3x. 3x minus 3x, 0. Okay? Which is just 1. And that's the answer. Okay? So this is simplification of indices when it's power-based, that's all. All right? So any question on this? Anyone? Natalie, any question?
No.
Okay, so good. So I'll just go through one last kind of indices question that you will have. So give me a minute. There is what we call solving for exponents questions. Okay, so it's questions like this. So the whole idea is very simple. Imagine if you have x to the power of a is equal to x to the power of b, right? Then surely the only logical implication must be a must be equals to b. Okay, and you will use this idea to solve for indices questions again. when the algebra or the unknown is a power, which we call exponents. Exponents means the power in general, okay? So you, just to give you some vocab, if you have x squared or x cubed, these are what we call polynomials. If you have really went through this in A Math in school, okay? Where the algebra is the base, the power is a numerical value. When you have things like this, 2 to the power of x, 3 to the power of x, these are what we call exponents or exponential functions under back to logarithms, where the algebra is the power, the base is a numerical value, okay? Okay, so the trick to solve this kind of questions, right, is always, we all know, is to link up the base so that we have a common base throughout. Then we can like for like on the powers, okay? But sometimes it's just hard to trick your way around it when the questions get more complicated, that's all. So I'll go through some, so you will go through some questions first. Okay, Pavan, you can go through the first one.
So it just becomes 2x equals to the power of 3 and then x equals 3.
Yeah, okay, so it's just like this. Then x is equal to 3 right away. Okay. Okay, then what if, okay, Natalie, what about this one?
2 to the power of 2x equals to 2 to the power of 3 and x equals to 3.
X is not equal to 3, yeah? 2x is equal to 3.
Oh yeah, 2x is equal to 3 and then x equals to 3 divided by 2, which is 1.
Okay, so the idea when you have 4 and 8, right, is pegged on the fact that 4 cannot be turned into 8 explicitly through raising of powers. You can, but it's complicated. Then you must recognize that both 4 and 8 are linked by 2, so you dump them both down to 2. Okay, and that's it then. So it's the same for subsequent questions. So I'll show you a bit here and there. So this kind, 2 to the power of x is just 2 to the power of 4. Okay, 16 is 2 to the power of 4 or 4 to the power of 2. So in this case, x is 4 right away. Okay, then this kind, same gameplay. So 16 can be turned into 4, so it's 4 squared. So x over 2 is equal to 2, x is equal to 4 right away. All right, then this kind, same gameplay, you must recognize that half is 2 to the power of -1, so x is equal to -1. Okay, sorry for the construction noise in the background. Let me turn off the windows, give me a minute. Okay, Natalie, try on the next one, this one.
2 to the power of 3x over 2 equals to 2 to the power of 5. And then 3x over 2 equals to 5. 3x equals to 10. And then x equals to 10 divided by 3.
Very good. Okay, so I don't think the remaining 4 questions we need to talk about. Okay, so when it comes to this, all right. Okay, Pavan, do the first one.
You can just divide first, right?
Yes, divide by what?
Yeah, so divide by 3.
Yep. Okay,
so then it becomes x squared equals 16. Then
okay.
you just square both sides.
So when it comes to this, don't forget the plus minus, okay?
Oh yeah.
So there is always a plus minus element in this kind of question. So the whole idea is you cannot have any more coefficients here. You must divide by 3 on both sides first to have a clean algebra on the left-hand side. Okay. So it's the same gameplay here. So x squared is equal to 9, x is equal to plus minus 3. Okay. Okay, Natalie, try on the next one.
Twelve x to the power of -1 equals to 2.
Okay, so you're multiplied by 3 across first, is it?
Yeah.
Okay.
And then will become, the left side will become 1 over 12x.
1 over 12x. No. If you look at this, is the power -1 applicable to x or the entire 12x actually?
x only. So it will become 12 over x equals to 2. So 12 divided by 2 is 6. X equals to 6.
Okay, understand? So you can choose to do something like this, or we can choose to do something like this also. So I want to isolate the algebra. So x to the power of -1 is equal to 2 over 12. Okay, then you must understand that when you have negative powers means you swap the fraction, right? So x to the power of 1 must be equal to 12 over 2, which is equal to 6, right? Okay, so both are accepted in this case. Okay, so you must be flexible in this kind of things. So watch out for the powers here, like this kind. Okay, in this case, the power -1 is only applicable to the x, not the 12. All right. Okay, so it's the subsequent kind of powers, right, that sometimes students get stumped. So I want to go through with you how to actually undo this kind of powers. So let's say if you look at the next one, same thing. The power half here, right, is only affecting on the x. It's not bracket up on the 2. Okay, so we will just isolate this guy, and this will give him 5 right away. Okay, then you know that you are trying to solve for x, right? So the point is how to turn half into 1. You must times 2. Okay, so x must be equals to 5 squared, which is equal to 25, and that's the answer right away. Get it? So I'm actually inherently, right, I'm actually superimposing a power 2 on both sides. Okay, and a half and a 2 will cancel off to give you a power 1 here. And power 1 is what we need because we are solving for x. Okay, Ken? Any questions on this? Anyone? No? Have any questions sound off right away? So, okay, so the next one is also fairly simple. So x to the power of -1 is thus 63 over 7, which is equal to 9 right away. Whenever I see this immediately, I know x must be equals to 1 over 9, flipping the thing around. Okay, so there is no need. I mean, if you want to, you can do that also. You can say 1 over x is equals to 9. So x must be equals to 1 over 9. This is accepted also. Okay. All right. Any questions on this? Okay, Pavan, you try the next one. This one.
Okay. So you divide by 2. You divide everything by 2 first.
Okay. So x to the power of 2/3 is equal to 16. Okay. And then.
Yeah. Then 2 over 3. You have to get into the power of 1, right?
Yep. That's the difficulty that most students face. Okay, so how do you turn 2/3 into 1? You must multiply with
3. Well, first you multiply it by 3.
Okay.
But then once you get to x, then we can manipulate the rest.
Okay, no, just think about this. 2/3, right?
Yeah.
So the idea is 2/3. What power must it be multiplied with to give you 1, actually?
Oh, you just multiply by, you just put it to the power of 3 over 2.
So it must be 3 over 2, so that there's a cancellation all along, right?
Yeah.
Okay, so we all know that you must impose power 3 over 2 now. This is the first idea, okay?
Yes.
Then the next part must be how to simplify then, okay? So we will have x to the power of 2/3. 3 over 2 is equal to 16 to the power of 3 over 2, okay? So the left-hand side will give you x to the power of 1 now. The right-hand side, so how do you simplify this? Press the calculator, is it?
Are we allowed to?
Sometimes yes, sometimes no, because the question may ask you to show working. Okay, so when you look at this, right? So the number 16 is pushed through a power of 3 and a power of half, right? Because the 2 is in the denominator. Okay.
But how do you do 16 to the power of 3 mentally?
Yeah. Okay. So no, one at a time. So let me I ask again. So there's a power 3 and a power half, right?
Yeah.
Does the power 3 upsize or downsize a number?
What do you mean?
So there's a power 3 here and there's a power 3 here and a power half here, right?
Yeah.
When you take a 16, you raise it to the power of 3. Does it increases or decreases the number?
Oh, it increases.
Okay, and a power half?
Decreases.
So you should always process the decreasing part first. Okay? So 16 to the power of 3, even if you can evaluate it, right, the number will be too huge to be handled already.
Yeah.
So you should always handle the downsize part first. So you string the number and you hope that you can actually handle it subsequently. Okay. So which means that we will see this as 16 to the power of half to the power of 3. And 16 to the power of half is? Square root of 16 is?
4.
Oh, so it's 4 to the power of 3. And what's 4 times 4 times 4?
64.
And that's the answer then.
Okay.
Okay, so you must understand this technique here. When you have a fractional power, you will process the denominator first, because the denominator actually strings the number, makes it more manageable in that way. Okay, and when you have power 2/3, you want to neutralize the 2/3, it's just times 3/2. So this is the key question in this handout actually, that most students tend to slump on. Okay, so be careful of this. All right. So the subsequent questions I think are fairly straightforward. You know that it's all about going for common base, that's all. So I'll just do I'll do 2 questions with you boys. So the first one will be this one. So 3 to the power of 12 divided by 3 to the power of 8 is equal to 3 to the power of 4, which is equal to 3 to the power of x. Therefore, x is equal to 4. Okay. Whereas this one is just 5 to the power of minus 2 plus x, put brackets, and 1 is just 5 to the power of 0. So therefore, x is equal to 2. Okay. Anyone, any questions on this? All right, Natalie, any questions on this?
No.
Okay. So this is it for indices. So you have only 2 kinds of indices. To solve it for when it's a numbers-based thing pertaining to fractional and stuff. And then kind will be when you have powers like exponents like this. Okay. So you need to get comfortable in both kinds. This will always be in E-math these days, no longer in A-math anymore already. All right. Okay. So I'll just move on to certs now. Where are we?